Okay, welcome back. So this is part 2 of the 8.2.1 notes. So we'll just say part 2, right? So number 7 here, I've actually already done it for you. You can kind of take a look and just see, oops, I meant to have decimals up there on the side. But as you're simplifying radicals, I've got 1 through 6 up above here. So you got 9 already simplified, 4 radical 6, 6 radical 5, 5 radical 5, and 16 radical 2. And then you got 8 radical 6, 4 radical 6, which is a repeat, so I apologize for that. 48 radical 3, but I thought I would show you how to do these last couple, and then I'll show you the bottom part as well. So -5 times radical 90. Well, they've got 9 and 10 that go into it. So you got radical 9, radical 10. Okay, and 9 is a perfect square, so that gives you 3, because 3 times 3 gives you 9. 10 can be broken down to 5 and 2, but neither of those are perfect squares. So 10 is really already simplified. So we're going to have -5 times 3 times radical 10, which gives you -15 radical 10. Okay, there's the answer on that one. Number 11, you got radical 21, which is 7 and 3, but 7 and 3 are not perfect squares. So in this case, again, anytime you have a number that's 21 or 30 or doesn't have a perfect square that goes into it, it is in fact already simplified. Okay, and then number 12, last but not least, this is 107. Both got to stay under the radicals because we haven't taken the square root until now. The square root of 100 is 10. So the answer here, 10 radical 7. Okay, there you go. All right. So there's our answers. Go ahead and take a look. You got 8 radical 6, 4 radical 6, 48 radical 3, already simplified, -15 radical 10, and of course 10 radical 7. Okay, so when you're multiplying with radicals, similar idea up here. At best, all we had to multiply was coefficients. But down here, we have actual radicals. Well, we're going to treat it just like they're numbers, but they're going to stay underneath. So this just becomes 2 times 3 when you multiply radicals, which is the radical 6. Okay, and if you can simplify this number, you should. But in this case, there is no perfect square that goes into radical 6, so that is in fact already simplified. Okay, for number 2, we have a couple coefficients on this one, 4 and 3. So we're going to multiply those first. That gives me 12. And then we're going to multiply the radicals, which gives me radical 15, because 5 times 3 gives you 15. 15 does not have a perfect square that goes into it. So once again, nice, easy multiplication, no simplifying there, because they're already simplified. How about 10 times 2? Well, that's going to give you radical 20, but here's the thing. Radical 20 does simplify because 4 goes into it, which is a perfect square. So you're going to have radical 4, radical 5, and the square root of 4 is 2. So your answer here is actually 2 radical 5. Okay? Perhaps a quicker way to do that, if you chose to, you could have broken down radical 10, saw that it was radical 2 and radical 5, and then because of that, you have 2 2's that are the same, so they go outside of the parentheses. So you ended up with 2 radical 5, whichever way you chose to do it. Okay, and then of course, last one here, I'm going to do a similar idea to what I just did. So you have radical 4 times radical 3, and then here you have radical 4 times radical 5, 2 4's, so that becomes a 4 outside of the radical symbol, and then 3 and 5 give you 15. That is not simplifiable, so that's it. Okay. All right, so there's your answers for the second part. This is the part 2 video. Again, and you got your answers up here as well. Feel free to pause and go ahead and complete the exit ticket. Your teachers today will have an answer key, and they will check it off, put their initials at the top, and then you can submit it. All right, guys, I'll see you on Friday.